Thank you. So thank you all for coming. So today we'll be having Rose Delilah Gesicho. She's an alumni of Moringa School. She was doing data science at Moringa School. The first time I met Rose was in the planning in Daba, the annual deep learning event that happens in Africa every year. So this year, due to Corona, we can't have it, but it came to Kenya last year. So we were very privileged to meet. And from there, she has gone to be a volunteer in Nairobi, Women in Machine Learning and Data Science, where she leads sessions and everything. So yeah, let me welcome Rose to continue the meeting.
Thank you, Bethany. I can share my screen. Can you see my screen?
Yeah, we can see the screen.
Okay, so thank you for having me, Bethany. I'll be taking you through the data science roadmap. And thank you for the introduction. As she said, my name is Rose Delilah Gesicho. I am a junior data scientist with a passion in natural language processing, and I have a passion in tech community development and neuroscience. So as she said, I organize events at Nairobi Women in Machine Learning and also Deep Learning AI, and also the learning program manager at Alliance for AI and working with Zindi as a country ambassador. So I'll take us through the presentation flow. We'll have an introduction and to data science, and then we'll go to the data career path, and then data science methodology, and how to begin exploring data science, sources to learn data science, and applications of data science. So the common ask question, and almost all presentations starts with, what is data science? So to me, in the simplest version, data science is a multidisciplinary field that uses scientific methods, processes, algorithms to extract knowledge and insights from structured and unstructured data. So the fact that it's multidisciplinary means it has mathematics inside, computer science, statistics. It's a whole bundle of course of fields that are gathered into one. And then the main aim is to extract knowledge and insights from data. They can be either structured or unstructured data. And if the knowledge is applicable for doing modeling, that's where algorithms come in. So most people ask why learn data science and why is it important? So the first point I would like to explain is you get to utilize abundant data. So data currently is the new gold, as all of us know. Whether you're doing web development and everything that you're creating for your clients, they have to input their data, and this is very crucial, and it's a lot because a lot of companies are now delving into data because they need to operate with data so that they get to know their clients' wants and needs. So a good thing about data science is that we have abundant data to work with. It also offers great job opportunities, as each company is now joining the data world. It offers like opportunity, even if it's maybe we can say data analyst or business analyst. As long as you're dealing with data, even cybersecurity itself is a career opportunity when you know something about data. Another point, it's in high demand. As I said earlier, many companies are joining the patrol of using data. So it's in high demand to get people with this talent. Then you learn diverse skills like problem solving. So if you're working with a company that wants you to find like wants you to solve a problem that they're undergoing, in the process you're going to learn such a skill. And then it's a flexible field. So as you all know, like data science is comprised of a lot of things like data preparation, which I'll take you through later on. and also machine learning, which is broad and it has natural language processing and a lot. So it's a really broad field that anyone can delve into, and it's subdivided. So you don't have to be like an extreme data scientist, but just having a little bit of something is enough. So I'll take you through the data science career path, and this is mostly some of the skill set that is required for this different type of jobs in data science. So as you can see, we have the data analyst. In this dark blue button means it's very important. So the programming tools skill is like programming, learning Python, learning how to code is important for all skills, for all career paths like data analyst, machine learning engineer, data engineer, and now a fully fledged data scientist. You need to learn how to code. And then there's data visualization and communication. This is very important to some for the data analyst and data scientist who is a collection of all these career paths. And then there's the data intuition, statistics, data wrangling, machine learning, software engineering. So as you can see with these most important dots, the data scientist has a collection of all of them. So that means if you want to be a fully fledged data scientist, you need to learn how to program, you need to know how to storytell, do data visualization, statistics, data wrangling, machine learning, and for those which are not very important but are somehow important, calculus and software engineering. So these are the key tech factors of being a data scientist. A background in mathematics and statistics. Yeah, that's quite, most people who do data science are mostly from the statistical background and computer science background. But to my opinion, I think everything is possible if you just put your mind to it. So personally, I'm not from either background. I'm not from the math background or the statistic background, but I managed to find my niche in data science. So I think you just need to believe in yourself and know that you can do it, but you really need the math in it and the statistics. So the background doesn't really matter, but you really need the skill set of math and statistics. You need to learn how to code in either Python programming language, R programming, and SQL. So Python is more simpler. Okay, to me, Python is simpler. R is okay to most people, and SQL is like a must-have. So that you can get data, like collect data from structured databases and stuff. So SQL is like a must-have, but for me, I prefer using Python to R. So you need to also understand databases in order to collect your data from them. You need to understand Postgres. You need to understand, it depends with the organization and what it's working with. So it's good if you just learn a little bit of everything to be safe. Depending on the organization you'll need to join and what they are using. And then we also have data visualization and reporting. Yeah, so this is like a must-have. You know how to, you must visualize your data so that you can drive insights, and also reporting. R is very good at reporting, creating reports. So that's one benefit of R compared to Python for me. And then there are key non-technical factors of being a data scientist. Yeah, you need to be curious. You need to be very curious. You need to ask a lot of questions about data. You need to know like why. You need to ask yourself a lot of questions before you conclude some findings, because that can affect the business a lot if you make a wrong decision. And then the business acumen, you just have to know the business you're working with. If you're working with a retail, you need to know how their business goes. You need to know what they do to support their clients. You really need to understand the business inside and out. You're part being a business analyst of it. You need to be business intelligent. Also, communication skills. You'll find like most of the people you're working with are non-technical. Maybe your CEO or the people you're trying to explain insights to, they are not technical. So you can't just go and say, so I used libraries like Pandas and Seaborn. They won't understand and it will be relevant to them. So you need to know how to communicate your insights. And then teamwork. Most data scientists don't work alone. I'm saying most because some startups data scientists work alone, but for most people who understand maybe data science, they know that teamwork, they'll be working together with are they called program managers or project managers and such. You'll need to work in teams in order to you'll need to work with someone who is doing the business bit of it, the person who is doing the data wrangling, so that you can combine all of them and drive insights. You'll just need to learn how to work as a team. It's important. So I'll take you through the data science life cycle, which we use the CRISP-DM methodology. So this is what we call the CRISP-DM, whereby it's like a step by step of doing a project or doing data science. So you start with the business understanding. You understand what the business does, and then you collect the data that is required. So you can do data collection you can collect it yourself, you can download it, you can web scrap, there are very many ways of collecting data. Then you prepare the data. Preparing the data means you check if there are outliers, null values, duplicates. You check if there's abnormality in your data. So that's how you prepare it, and you have to be cautious and prepare it thoroughly before it moves to the modeling phase, because it can affect your model's performance if it's not thoroughly prepared. So that's why most people or data scientists spend 80% of their time preparing data. And then you do the exploratory data analysis. Here's whereby you do like univariate, bivariate, you do visualization, and then you try to just get insights from the data before you can go to modeling. Then from the modeling bit, you go to the evaluation. From the evaluation is where you just use a confusion matrix. You just try to evaluate your data and using the accuracy, checking the accuracy score and trying to improve it. And then for the model deployment, it's where you can deploy it in a web application, in an Android application, or even, it's where now you store your model so that it can be used by the users in a good user experience platform. So where can you start? First, you must start by learning a language. You can't just delve into something without learning the fundamental language. So you can either learn R or Python or both. So you have to learn at least a programming language. Read 1 or 2 introductory books. Personally, I used to go to any books and then just search Python for data science, and then I will try and read it, which obviously I could not complete it. And then take 1 to 2 introductory courses and watch some webinars. So you can go to Udacity and Coursera. They have very good introductory courses whereby you can just start yourself, just kickstart your journey and learn what data science is all about and how to start, and even watch some webinars. There are a lot of webinars people are putting up on how to do data science, either in medicine or in education. So you can always watch out for some. And then you can attend boot camps. As Bethany had said, I joined Moringa School with no knowledge, absolutely no knowledge about data science. And yeah, I can say it was really beneficial, and I got a lot of knowledge from learning through their courses and everything. You can also learn from African Data School or Modcom. That's what it's called, yeah. Modcom, or those are boot camps in Kenya. So yeah, you can try any of them if you want to join a boot camp. You can also participate in data mining competition. So you have Zindi and Kaggle. I personally go for Zindi because it deals with African problems and has data sets on African problems. So that's something I love doing. I love competing. Sometimes I don't complete the competitions, but I learn something new each time that I start. And yeah, hopefully one day I might be among the top people in the leaderboards, but this helps a lot in learning data science. You get to interact with people, with other data scientists who are going to like empower you with some knowledge and tell you where you're going wrong. Maybe they can just simplify your processes and just inform you of courses you can take so that you can learn more. So yeah, I think that's very important. Dealing with competitions, you learn a lot. So where you can get your data, you can get data from Kaggle. You can also get data from Zindi, Amazon, opendata.go.ke, BigQuery. So BigQuery, when you're trying to get data, you have to write queries. Yeah, that's a good learning experience for sure. Yeah, and this other, the one for Zindi and Kaggle are usually somehow structured, so it's easier for you to get them. So what's next after you've studied and you have gone through the competitions and you have gotten your data? You can start by doing projects, step by step, just doing projects, simple projects. You can try and make a team and subdivide work and then come together and then learn from each other. You can also participate in the Kaggle competitions, the Zindi competitions, and other hackathons e.g. the MIT hackathons. You can learn a lot from those international data science gurus with PhDs. You can also do the hackathon like the one I saw recently being advertised by Moringa. Is it the Africa something data? Yeah, just a lot of data hackathons that are usually put out, the Umoja hackathon. So that's somewhere you can apply your knowledge. So after that, you just don't sit on your work. You can blog about it on either Medium page or even on your own website if you have one. You can tweet about it and get to learn from other people of how they would have approached the certain problem. You can also write a technical paper or posters or even speak at conferences, and then you'll get opinion from other people and you'll get to learn from that too. So mistakes to avoid when starting out as a data scientist. First, spending too much time on theory. As I said earlier, when I was really new to data science and I was a bit scared that I'm going to a school with gurus, with statistical knowledge, I took a whole book and I started reading. I never even got to page 20. I was already tired and I was like, what am I even getting here? There's no code written, and those codes written, I never even understood how they're implemented. So don't spend too much time on theory because you'll just not, most of the things you'll even forget before you try to apply. Some things even I read from that book, I don't remember. So it's just like a bit waste of time. So don't spend too much time on it. coding too many algorithms from scratch. I know some sites say it's okay to do that. Yes, it's okay if you're learning from it, but just don't spend your whole time trying to code a whole algorithm from scratch, and by the time you're done with it, another version has already been released and it's more effective. Just, you can go with the flow, but if you're going to start learning from scratch, you can just put your main focus as learning. You're learning how to program it, not like you want to implement it directly. Just use it like a learning path. And then jumping into advanced topics directly. Yeah, this is something I also did. I've been fascinated by NLP a lot. So instead of learning the basics, I decided that I wanted to make a Jarvis or a personal assistant like Google. I went and just Googled how to make a personal assistant. I don't know what I was doing, but it did not help because even the basics I never understood. So I can show you like a quick thing that I started doing this June so that I can stop being all weird. So this is something I'm doing for this June. I'm documenting 30 days of NLP, whereby I want to learn how to create a chatbot. So I just break it down. Day one, I learn like the two variants, and then the requirements that I really need to learn, like they're very important for every chatbot. And then each day I leave a future scope of what I'm going to do the next day. Day two, the same. And then I write code. If it fails, I document it. So that's something I'm working on currently, so that I may avoid just jumping into advanced topics like the way I thought, and I wasted a lot of time Googling and expecting to be really good at NLP just because I was jumping into creating something amazing without knowing the basics. And then overestimating the value of academic degrees. So this one I can explain it for others, for other people, where I had that having the knowledge in statistics made their way easier into data science because they were able to understand some statistical things like p-value, t-statistics, t-test, and everything, which for me it was very new because I have not learned anything like that. And for them, it was really easier, and they really understood like how to implement some algorithms because of the background they had in computer science and statistics. I don't have a background in both, so I don't really know what's taught, but it's an advantage. Being unprepared to discuss projects during interviews. Yes, I know sometimes we have the imposter syndrome, but I think it's okay to fail, and then you learn from your failure. I know a lot of interviews. There's an interview that Moringa has like for the end of know your whole course. That interview was hectic, and I was like, oh, I don't think I'll go back to data science. But I think you just fail and then you learn from your mistakes. So everything that the interviewers told us, I put them into practice, and every day I'm just trying to make myself better. So it's okay not to be very prepared, but just go and do your best, and then discuss your project and explain to them how you derived the insights. That's okay. Just try. Underestimating the value of domain knowledge. Most people jump the business understanding bit, and it's very important because you need to know how this business operates. So if you jump the domain knowledge, you'll be trying to solve your own problem, not the business problem. Neglecting communication skills. yes, don't neglect communication skills, because at the end of the day, you'll need to communicate your findings. So if you think you're just going to connect to the technical people, it's a lie. You'll need to communicate to people who have no technical background, and you really need to explain to them how whatever you're making is going to be good for their business, because eventually they'll be paying you a lot of money for that. So you need to know how to communicate and sell your products yourself. You need to sell your model to them. So you need to know how to communicate well. So this is the application of data science, where data science is can be applied in the finance industry, doing risk analysis, fraud detection in the retail industry, doing customer segmentation, building a recommender system. In the healthcare, you can do drug discovery, genomics. In the education industry, innovating the curriculum, measuring instructor performance. Data science is really broad. You can actually apply it in most industries. Yeah. So the main takeaways, you understand the data science life cycle, like the business understanding, and then you collect the data, and then you prepare the data, and then you do some EDA, and then you go to the modeling bit, evaluation, and then deployment. That's very important. And then learning how to learn, and learn by doing. So you should learn how to learn on your own. Go to GitHub pages, go to Stack Overflow, go to Udacity, go to discussion rooms of Kaggle and Zindi, and learn from other data scientists. And don't just do theory plus technical bit of it. Do the theory to know the background, but also do the technical bit so that you can, it's important to practice it. Don't just read. And then you can share your work via the blogging, social media platforms. Yeah, so that's something important. I would like to show you guys just how a basic project may look like. I'm not going to go to dive deep into what the project is, but so if this is a project about hypothyroid disease, and the problem statement is we want to know whether a patient has a hypothyroid disease or not. So you first start by drafting or writing the problem statement. No, first you start by understanding the context. Sorry. So you have to understand what hypothyroid is about, and then know the problem statement, and then you can write the metric of success. A metric of success is what you aim to achieve at the end. So here you can write an accuracy of 98% or something like that. And then you record your experimental design. So you can start by what you have done. You first collected the data, you read it, you described it, you checked the outliers, checked for multicollinearity, built a baseline model. So this is just like what you have done with the project. And then data relevance. To me, for this project, it had no data description. For others, you can say the data was biased. It focused more on this than this. So then here you start with data cleaning and preparation. You can import your libraries. After importing, you do data description. So it's like investigating your data. What shape does it have? Does it have the column and the number of rows? Describing it, just describing the number of duplicates it has. You drop the duplicates. You look for null values, check if you can impute them or just drop them. Look at the data types. Are they relevant to the columns? And then you do some EDA. You can do univariate. You can do bivariate. Bivariate is just checking how many males have hypothyroid, how many females have hypothyroid. You can check here. Most people don't have the hypothyroid, but we can also check here females are the ones with the most hyperthyroid. And if you checked well at the business understanding, you can also understand maybe females are more prone to catching hyperthyroid. So the domain knowledge is very important. So for someone who had not read about the business understanding, they would have said the data is biased, and maybe it's not biased, it's because females are more prone to getting the disease. So after that, you can do some multivariate analysis, some PCA, and you can normalize your data if it's not well normalized, and then you can do encoding. If it's a categorical problem you're solving, you can encode to zeros and ones, and then you can begin your baseline model. This is like the basic model you can ever build without complications and without trying to improve it. And then you build other models to check if they can perform better than the baseline. And then you, with the models, you try and improve them by doing regularization, boosting methods, and everything like that. So yeah, you just tried different models. That's the random forest. This is the support vector. But you just don't put models there. You have to look at the problem at hand and then choose the model that you want to investigate it with. And then after that, you can conclude with some conclusion of which model did better than which model. And then you can challenge your solution. And then maybe you can go up again and then try and see, if I had not removed the outliers, how will the model have performed, and such things and such things. So that's basically it about data science. So any questions? I hope I haven't talked too much. But any questions? Hello?
Is there anyone with a question?
Hello.
Hello.
Yeah, this is Michael.
Okay.
Yeah, I am a beginner. I am just getting into data science, but transitioning from another field. But from the initial presentation, where we were talking about the tools that you need for data science, something like Excel. Where would you place it?
So currently, okay, how you'll place Excel. Excel is also a tool that you can use to collect data. So some data come in Excel sheets, others come in databases. So it won't be as such as a programming language, but it's something that I will place it in maybe where to get data from, like a source of data, because you need to collect the data from the Excel sheet, which is already like well played for you. Most of the data science projects are usually in CSV form, so it's just easy for one to retrieve them. So I will put it in the sources of where you can get your data from.
Yeah, and the reason why I'm asking that is because Excel, I've just come to find out, and especially when you take a look at advanced Excel, has quite a number of functions, even linear regression kind of stuff that you can actually apply. That's why I'm saying starting with the simple tools. What is this that I can be presented with that will take me outside Microsoft Excel? Say, for instance, I'm also learning the two languages, I have the advantage of having gone through the programming level before. So I'm taking a look at the two languages, Python and R. SQL, I know a bit of things here and there. But what is this thing that will get me out of Excel that will now require me to bring in the R's and the Pythons? In other words, what I'm trying to say is that I wouldn't want to get a hammer to kill a mosquito. The mosquito will die, yes, but I'll have taken a lot.
Sorry. Is Michael still talking?
Yes, I'm here. I had actually completed, but my question is getting straight to it. At what point do you now say that you say okay? Let me start it here. If I am to compare two variables and get to see how they compare against some data, that we can do in Excel, right? So my question is, at what point do I now realize that I will need another tool that is more powerful than Excel, that it's not just a matter of drawing graphs and some pie charts and I'm done, so that I do not use a lot of energy solving something that I can just simply open up an Excel and put in some figures there, that is my data, and Excel does the magic for me. That's my concern.
Personally, what I can say about that, I haven't used Excel so much, but why I can prefer using the programming languages compared to using the Excel. Most data won't come in the structure in which Excel is put into. We have like data which is very unstructured and data which it's not collected in the way Excel does it. You get? So that's why the pandas and the Seaborn work in a way to try and organize that. Like it's easier to use the pandas and stuff. I don't know if Excel can just, if it's supposed to okay, big data, like use large amount of data and work on it and manipulate it further and even draw insights. I don't know if it works. It can organize it in that way. But for me, what I know, for using the programming languages, it can work with data which is not structured in an Excel format, because there are very many formats in which data come in and in which data is retrieved. Some other ways are like hydrating data. How can you hydrate data in Excel? People collect it in a JSON format. You get? So I think there's some things that limit using Excel as a method of doing data manipulation. That's why most people believe in using the Python, which has libraries already set in place to manipulate data for you easily, and if it's maybe a lot. Have I answered you?
Oh yeah, that explains, especially the data structure itself. Kind of explains the importance, and then again the libraries. When you have to get a library to do the stuff for you, which has already been set up, then that makes a lot of sense.
Okay, thank you for the insight about Excel. I think I will also look into it. Any other question?
I'll have a lot of questions. I don't know whether I'm taking a lot of airtime. Probably I allow someone else to come in.
You can go on.
All right, we do have other tools, the Power BIs, the Tableaus, and so on. Yeah. Where do we get this? In this whole picture, where do we get this? Where do we put this?
So I'm familiar with Tableau.
Yes.
So Tableau is used for data visualization and storytelling. So It's easier than writing code, honestly. Okay, for some people. For me, it brought a lot of issues, but maybe it's because I preferred writing code too. But it visualizes data well, and also aligns them in a dashboard. So I think the main idea behind Tableau is maybe to show a non-technical people in an organization, like without writing a lot of code, you just drive insights from data for them, arrange them in a dashboard, and be able to do storytelling to them and just tell them what you got from the data, how you analyze the data, by just showing them what they can physically see, what they can see without being very confused. So it's more of a data visualization tool.
Okay, I get that. Thank you very much.
Yes, I think. Ganesh, I have one question.
Okay.
You're gonna drag me into this, all right? So, no, this is kind of a out of context question. I just wanted to ask, what is your favorite dish and why do you like it?
Sorry?
What is the favorite dish? What is your favorite thing to eat and why do you like it?
My favorite dish?
Yes.
Food.
Yes.
Sorry.
Yeah,
My favorite
I was
food.
just talking to Herji and he was said like, go ask her something. I I didn't know what to ask.
Oh, I thought
I was not also, I also was not going to ask, but Herji dragged me into this. Now I want to know.
Okay, my favorite dish. Oh, I am a foodie, so I eat everything. But my most favorite dish is burgers and pizza together, and fries. I usually like combine all of them and eat them together because okay, they're not nutritious, but they make me feel good. They make me feel. That's why I love. That's something I love about them. They make me feel comfortable, happy, calm. Yeah.
And if I can share my screen right now, I will show you how much Herji is laughing. I just
How much?
it's like let me just share it.
Yeah, Ganesh is crazy.
Okay, can you guys see my screen?
Yeah.
Okay, so here in the chat, hey, let me see. He's tying up. Yeah, don't worry about it. You feel a lot tense. Don't.
Oh, what is your problem?
Feel free, okay? You did a
I'm not
great job.
angry.
I was here. I was here for the
What?
whole
I
session.
don't think my
Is this part of the session?
No, this is not the part of the session. Sorry, don't want to disturb any one of you. I'll just go in my pet again. Bye.
It's okay.
Anyone else with a question?
Bethany, Rose.
Yeah.
Yeah.
Yes, Michael again. It's good that you have been exposed in some of the things, and it's good that you are already attached to some of the organizations who have opportunities. I know one of the things that really give people who are getting to know what data science and any other new field is all about is practical experience. I can look at some data that is out there, but if I have someone who is holding my hand, that will accelerate the path to success. For beginners, how can we take advantage of this group that we have here to get mentors and stuff like that?
So I know okay, I don't know about the Microsoft team, but all I know, if you join communities, e.g., like the one that I'm currently, the Nairobi Women in Machine Learning and Data Science, there are a lot of people there who are advanced and who are always willing to help. I know of someone called Katie. She has a PhD in Caltech, from Caltech in AI, and she actually does robotics, and she's very helpful. She's good at mentoring people, and she's also very open in assisting. So in these communities, we should not take them for granted. There are a lot of people we can learn from, and even if it's just your beginner friend, as long as you guys are just working together and are consistent, and obviously among all of you, there's someone who is a bit advanced or in the intermediate who can give you some pointers. So I know you'll move at a slower beat, but you'll get there somehow, somewhere. You can also use social media platforms like LinkedIn. There are a lot of people there who venture in data science. These hackathons, these Zindi platforms, which have discussion room, the discussion section, you can be a part of it when you're dealing with a competition, and then you can get those people to communicate with you, to be your mentors. You can ask people even online on Instagram to be your mentors. Personally, my mentor is abroad. She's a machine learning engineer, and I got her from Instagram. I just saw her posts, I liked them, and I asked her, can you please mentor me in natural language processing? And then she said, it's okay. I can give you my GitHub, check on it, and if you have questions, you can ask me. So I think there's a good platform for data currently, and a lot of people who are willing to help. So just leverage your communities. There's Nairobi AI. There are a lot of communities, and there are a lot of people who are experienced and who are always willing to help. So I don't think you can walk alone, this journey alone. If you just decide to humbly approach someone and ask them for help and for mentorship and for guidelines. Yeah. Is that okay, Michael?
Yeah, that's okay. You had actually mentioned of some groups that are in Kenya.
Yeah.
Probably Nairobi. Can you just go over that again?
There
was Nairobi Data Science.
Yeah.
There was Nairobi, if I remember right, Nairobi Data something or Africa Data something.
The boot camps.
Oh, these are boot camps.
There's the boot camps in the communities. The boot camps I mentioned, Moringa, Africa Data School, and Modcom. I'm not sure it's called Modcom, but I think it's called Modcom. Yeah, but those are the three I am aware of. And then communities, unless I just put a long list of the communities I know of, there are a lot of communities dealing with data science in Kenya. So joining either TensorFlow, Nairobi, and all those other groups will be very beneficial.
We have a question from Ibrahim. Ibrahim.
Yes, hello, can you hear me?
Yeah.
Yeah, so it's not much of a question. I just wanted to reply to Michael. Yeah, so he had asked about why we would need to move from Excel. So I think, in my opinion, I think for just basic data analysis, I think Excel is okay. But now when it comes to things like machine learning and making predictions, I don't think you can do that with Excel. Rather than, I think, just basic regression, I don't know if you can do other kinds of prediction. And then there's this other point about unsupervised learning. So this is where you're given data without labels. So you try to predict without having necessarily column names and things like that. So I don't think you would also be able to do that with Excel. So as you get into data science, the early stages, the data analysis part, I think it is okay with whatever tool you can use, whether it is you're using SQL or Excel or even Python. For the first part about data analysis, I think it depends with you and the kind of interface you like to use. But now when it comes to prediction, I think you have to move into Python or R. And then the other thing is about things like data engineering and data modeling. So with Python, you can be able to represent your machine learning model as things like a web app. So you can be able to build a web app using Python. So I think those are some of the things that would put Python. Mic check. You can hear me?
Oh, you're back.
Yeah, so I don't know what part you had me. I talked about unsupervised learning. Mic check.
Yes, you talked about unsupervised learning. There was a part you talked about data that is not labeled. You're trying to explain. The part after that is where you disappeared a bit.
Oh yeah, so I was saying about when you're deploying your model, you can have it as a web application. So I think with Python, you can be able to build a web app. Unlike with Excel, where you can't do things like that. And also for data engineering, I think Python is way ahead. Are we good?
Yeah.
Okay, yeah. Thank you.
Yeah.
Thank you, Ibrahim.
Is there anyone else with a question?
I don't have any questions, but I just wanted to say before leaving, this was a great session. Keep doing the great work you're doing, and bye bye. Okay.
Thank you.
Okay. Okay. Since there's no more questions, we can end here. Then the slides will be sent to your emails if you RSVP'd, or you can find them in the group. And thank you so much, Rose, for joining us.